We are just wrapping up with Jeff Line here at CoolIT Systems, and he's just going to kind of recap, a little bit, I think, about what CoolIT was, what CoolIT is, and where CoolIT's going.
Well, I think we also had a question stream in on pump development,
right.
And basically what I wanted to highlight here, which we also showcased at the Consumer Electronics Show, was some of this additional development that we've done recently. We've actually walked away from our previous pump because in some applications it was too big, some applications it was too small. So what we've actually done instead is have two different models of pump that we've developed. The compact form factor 1, which is a CFF1 that we call it, or most people would know it as the domino pump. It's actually extremely compact, actually built in, it has obviously a regular power connector, but it also has a temperature sensor built into it so that we can understand what the temperature of the coolant would be at all times. This pump is not only life rated at over 55,000 hours, but it's in fact both of the compact form factor, the HFD5, which is actually based off the D5 pump from Lang. So we worked together with Lang to put the D5 capabilities in a rather compact and flexible format together with our barge system, so that we can actually have this integrated in some of our more elaborate systems, like, for example, what's going to Dell in the XPS 700 series. So we have two kind of right-sized pumps that gives us a lot more flexibility when we're doing system design. Both pumps have actually been proven for their longevity and being leak-proof as well. Not only at 50,000 hours, but 50,000 hours at 55 degrees Celsius, which is a rather extreme spec. Quite frankly, to my knowledge, it's the highest specification for any pump reliability that's out there. So if you compare it down to 40 degrees Celsius, which a lot of other pumps are claiming their longevity to be at 40C and 50,000 hours. At 40C, comparatively, that would put these pumps at well over 100,000 hours. And at 30C, it's actually close to 1 million hours. So the accelerated life test becomes less relevant from where you go. But we're extremely proud of the achievement of developing both of these pumps, and looking forward to quite frankly never having a pump discussion. It's the kind of thing where no one ever talks about a pump unless it's something bad. So we want to have an ability for these pumps to not only pave the way for our customers' reliability, but also provide us with the flexibility that we need to have the custom system building that we've become known for.
So back in the early days of water cooling, people always, the big rate was flow rate versus, radiator performance, and people figured you needed at least 100 gallons per hour or better pump, or even some people are like 300, 400 gallons per hour. What is the actual gallons or liters per hour of the smaller pump as well as the larger pump?
Well, it's a bit of a joke, quite frankly, when everyone's quoting what the flow rate is on any of these rated pumps. A flow rate is a curve, and the curve starts at free flow, which basically means it's not going through any tubing or anything else for that matter. So usually these monster numbers that you hear on the per hour basis, I don't have that kind of patience. We usually do things by the minute. So in that perspective, the CFF1 pump for free flow does about 2 liters a minute. In the domino, for example, it does about 1.2 liters a minute. In reality, if you get right down to the physics of it, it comes down to that volume flow compared to the hydraulic diameter of the liquid block. So the velocity of the liquid as it goes past the heat exchanging surfaces is really what matters. So since I don't see anybody reviewing typically what the surface area and hydraulic volume is for each of the individual water blocks, it's extremely irrelevant what happens. For ours, as it comes down to it, we don't have any detriment to performance in terms of the heat exchanging capability of the liquid block. until we get well below, you know, 400 milliliters a minute.
Wow.
So we're using microchannels, which have a very, very fine pitch.
Right.
The liquid's going extremely fast through there, so you get to a diminishing return very quickly.
Absolutely.
But frankly, if you put this giant pump, which can push out upwards of, it actually consumes about 18 watts
Right.
when it's going flat out. So 18 watts is significant in terms of the heat, and it goes into the liquid.
Right. Yeah.
So you take a domino, put a giant pump on it, it'll actually perform worse because you've just injected 18 watts of heat.
Yeah.
So you know, it's a bit of a engineering
Right.
philosophy, but in the end, we feel that there's really no benefit of going to large diameter tubing or, you know, these monster pumps.
Right.
It's somewhat, I think, akin to in the hot rodding world, you know, putting a fin on the back of the trunk. That doesn't make it go any faster.
Right. I find it quite comical that you talk about the pump based off the Lang pump as being a monster pump. My first water cooling kit was the pump was the Eheim whatever, and I think it weighed like 6 pounds just the pump alone. Like, it's just a monster pump, all ceramics and all these stuff is much smaller, and everybody's changed their tune. But I guess maybe the microchannels have something to do with it based on how water blocks were designed previously?
Yeah, well, there's a lot of advancement that's taking place, and, you know, I think that all of the companies that are involved in liquid cooling for electronics have various different strengths and weaknesses. You know, the ability to design, purpose design a water block to be universal, you know, and it potentially hasn't changed its surface exchanging technology, you know, for the last 5 years.
Right.
And that, you know, the dies internally on the chips have changed. You know, it's gone from bare die in the old days. You know, now they have IHSs or capped, depending on whose company you're talking about.
Yeah.
You know, the overall efficiency, if you purpose design something specifically, there's really no use in having, you know, fins or pins on anything other than where the heat is specifically. You know, there's not a tremendous amount of spreading that takes place when you have liquid whisking the heat away as quickly as it's created. So the you know, the engineering that's required to really optimize that is pretty specific. There aren't many that would have a tremendous benefit from going through it, because what they are doing, like, I don't want to take anything away from the kits. You know, there's a lot of really good quality product out there, and they perform great. You know, the pin structures that good quality blocks are using now, they actually do improve dramatically with more flow.
Right.
Because, you know, it's a pretty good ratio, but you can design around that if you need to.
Absolutely. Well, thank you very much for your time, Jeff. I appreciate that. I know our readers will be very interested. And too, on a side note, I was talking with Nick over there in marketing, and you guys are going to be, whether you know it or not, sponsoring Volkland in March 13th to 15th. So just want to shout out. You guys can go get registered for that. I don't think we'll see Jeff there, but you'll see some of his products there and get a chance to win a couple dominoes. Thank you very much for your time, sir.
My pleasure. Glad you guys had time to come visit.